All, this is Junior Scientist, and today we are going to start a subject book which is about chemistry, and particularly it will refer to the class IGCSE related to different boards. In today's discussion, we have just started our lecture, which is lecture number, topic number 2.2, which is about separating and purifying substances. In this particular topic, we'll be covering something, various techniques which are used nowadays for the general purposes for the separation of different gases from liquids to the various solids. In a simple way, we'll be using three basic states of matter to get separated from each other by using general or more easy techniques which everybody could use them who have basic knowledge of chemistry or science. Now we should be careful about certain points. It's like to make use of material, the world around us, we need a method for the physical separation which are obviously used to separate many other mixtures from each other. So in a simple way, we are trying to develop some sort of basics which could be helpful for us to separate different substances from each other. In a simple way, you have to be careful about the separation methods, about which purposes you are going to do separation for. In a simple way, the most useful separation method for a particular mixture depends upon the type of mixture in which you are engaged in. You want to separate off, maybe you want to separate liquid from the gases or gases from the solids. So in a simple way, you should be clear about the facts. Are you going to deal with the miscible solution or mixture? Are you interested in immiscible solution? So you should be care about like how you're going to do the separation and what would be the result of the separation. Next factor is like which substances in the mixture we are most interested in. Let us say we have a mixture of salt and water, and you should be clear about either you're interested more in salt, either you're interested in water. So in a simple way, you should be clear about which substance you want to drag off. Just like the way if we have mixture of substances or metals present on, and we should be careful about, or we should be clear for about like how or which substance we are gonna separate with. So that is all about with substance. It's like the substance priority and which type of mixture are you going to deal with. Even you have a detailed knowledge of that particular mixture, like either is miscible, immiscible. So accordingly, you will develop some certain techniques to make the separation process to go on in a smooth way. Now, the first point is separation of insoluble solids from the liquid. So obviously, if you use this technique, or you should be when you find this word, this insoluble mixture, this one, obviously the things are quite clear. So if you want to separate the insoluble solids from the liquids, that is the easiest way. So simply if I want to ask any guy, he would be saying like you can stain the insoluble solid particle from the liquids. That way it's be the easiest way to separate them. Now what they are referring the term in chemistry is the decanting. It simply means like once the solid has settled to the bottom, you can simply pour the pure liquid off. Now there's another strategy. Either you should boil it off, either you should condense it, but in a simple way, you have to develop such strategy or such method with which the solid could be settled at the bottom, so that all the solid insoluble particles would be staying right at the bottom, and you can separate the clear pure liquid from them. So that was all about the separating insoluble solids from the liquids. Now the next case is about the general scenario related to the mixtures, and side by side we have the method of their separation. Now the first method is when you have mixture which is paired by mixing up two solids, but they should be in the powdered form. What do I mean by this concept is that let's say you have accidentally you have mixed off salt and minute particles of magnets. Now how would you separate them? That is dependent upon four basic methods to separate them off from each other. What they are engaging is like density. You should be concerning about density. Obviously, if you place salt and what is it, the magnet in one solution, the one who is denser would settle at the bottom, and the one who has lighter weight or who is lighter denser would float right at the surface. Next case is solubility. That is the most beautiful strategy to separate the two. Let us say if you have a mixture of magnet and salt, how would you separate them? Simply, you need to consider like at least one of the solids must be solid in one solvent. So simply, I would be using water because salt is soluble in water. So if I would add the entire solution or the entire mixture within the water, water will dissolve salt and the remaining thing which is magnet would easily got separated off. Next thing is sublimation, which is obviously not applicable to this thing, but simply as a procedure, it is a method of separation of something which is solid and it just immediately converts itself into the gases. Usually, carbon dioxide is known for this purpose. So, simply, sublimation is a process when a solid directly converts itself into the gaseous substances. Next is about magnetism. So let's say if you have mixed of two metals into each other or two magnets into each other. Now you have to apply the opposite pole that is going to drag the solid particles towards itself. In other case, the same example for the salt and magnet. If you apply magnet to that particular solution, that magnet is going to drag all the magnetic particles. Obviously, we will separate magnets. The remaining leftover material would be salt. So that is how this separation is possible. The next point is suspension of solid in liquid. Now, let's say there is some sort of solid particles who are present within the liquids. So for that purpose, you can use filtration or centrifugation for this separation. What do I mean by these two strategies or techniques is that you can use, and blood is the best example of this case. So simply, we will focus on the centrifugation. The centrifugation applies to the blood, or this is an apparatus within which multiple tubes or test tubes or like minute tubes are present basically. So within that thing, we are going to apply our sample and we have to force it to move fastly. So it is going to run up so fast. It's like it rotates multiple times during 1 second. So due to that faster rotation, it is going to separate blood and the remaining solid particles in a better way. So we can separate solid and liquid from each other. So biology student would be clear with this fact, like it is a technique with which we can separate serum and plasma. Next is the case when you have two liquids, but now these two liquids are immiscible within each other. With this thing, I mean to say that immiscibility is when two liquids are not that soluble into each other. They are not, I mean, like they have density differences. So, simply oil and water are the best example of this density based differences when you can see some droplets of oil like available right at the surface of water, and you can clearly say like they are not soluble within each other. So for this purpose, we can use a separating funnel or decantation process to separate them off. So obviously with the separating funnel, we will be placing the two, the one who is having lower density or the will stay at the surface and the one who is having higher density would stay right at the bottom so we can separate them later on. Next point is solution of solids in liquids. Now, in this case, when you have a solution of solid, you should be clear like now in this case, the solid is being soluble within solvent. So, in this case, the best example um, would be salt and water because salt or sugar, they are quite soluble within water. Now, to obtain the separation, we can use evaporation. It's like when we could evaporate something from a solvent. So we are going to put on the solution on heat in case of crystallization. Upon heating it, it is going to separate the crystals from water because now we will simply, upon boiling it off, the crystals would available right at the bottom and water would obviously got evaporated. So the leftover material would be the crystals of salt so we can separate them from each other. The next process is if you are interested in liquid or you want water to get rid of that salt or simply you want to purify the sea water, so we will be placing it within a distillation chamber or distillation machine or distillation apparatus. So it engages the process of condensation within this entire process which we will study in the later on lectures. Now, this distillation is going to separate the liquid from the salt. We are going to run it off. We are going to first boil the water. It is going to convert water within the vapors, and later on, we are going to apply the process of condensation to cool this entire solution or the vaporous material. Now, later on, when as soon as it gets back to water, when it converts itself from gaseous to water, it is going to be the water which is now salt free. So that is how we can separate the solution of this entire solution which is solid in liquids, so by using the process of distillation or crystallization. Next is the process. It's like when you have two or more liquids who are miscible or mixable into each other. Now, the two terms, immiscible and miscible, they are different. When we refer to the miscibility, it means two solutions are soluble into each other. They are entirely mixable into each other, just like we have like ethanol and water, so or maybe alcohol and water in a general way. So how would we separate the two when they have the when they are completely like comfortable or soluble into each other? The best way is to use fractional distillation. Now, fractional distillation is what we could say that it is an apparatus which would separate the mixtures of liquids on the basis of their different boiling points. Now, ethanol boils at 78 degree and water boils at 100 degrees Celsius if both of them are pure. Because in case of presence of any impurity in them, they are going to show some sort of either elevated boiling point or either declined melting point. So that is a way to identify the two impure substances. So since like multiple substances or sorry liquids are soluble into each other, we could use various strategy to separate them. And in case of liquids, the best known strategy is like fractional distillation. So we would use this technology or this apparatus because it separates the two liquids on the basis of their own boiling points. It is going to show, like in case of ethanol in water, since ethanol has lower boiling point, so ethanol will evaporate or entire ethanol will evaporate at 78 degrees Celsius. Whenever ethanol evaporates, the leftover material or leftover solute we have is water. So obviously we can separate water later on. The next case is a solution of two or more solids in a liquid. Now you should be clear, it doesn't, like liquids in a solid could be possible. Mostly we use chromatography for the separation of two to three liquids from each other by using the process of chromatography. Remember that when we have three to four inks mixed within each other, you can easily separate them by using the process of chromatography. And at your level, paper chromatography is hardly used, and you can simply put in a mixture of spot onto them. Later on, everything is going to separate. So another case is in case of solids in liquid, you could use proteins, liquids, or lipids when they're miscible in some liquid. So that is how you can separate solids from the liquids by using the process of chromatography. So that was all about the general review. What if we get into a bit detail? Simply, a more general useful method for separation of solids from liquid is filtration. Here, the insoluble mixture is referred as residue. So, insoluble hard material or solid particles are called as residue. They are left onto the filter paper. They are called as residue. And the filtration is useful because both phases can be obtained in one process. It means you can separate a residue and filtrate from each other. So, the solid separated on is called as residue. The liquid separated on or the liquid purified is called as filtrate. The process can be used by using a vacuum pump to suck up the liquid through the filter paper in a Buchner funnel in a flask. The best way is if you have passed the entire material or the mixture through a filter paper after being doing like every process which was mandatory. Now it have left over some crystals onto the filter paper and the filtrate got separated up. Now what happens, like the one who is staying at the filter paper, the one which is the solid residue, might contain some sort of moisture into it. In order to get rid of that moisture even, or that water or that liquid content even, we should refer or we should use this vacuum pump, because it is going to suck up or collect up all the liquids or moisture which is present in the residue. So that is the way how we can do this. The next process of separation of insoluble liquids is from, I mean, like insoluble solids from liquid is filtration. So you have to spun filter centrifuge at a higher speed. Due to its higher speed, it is going to separate the solid and liquid from each other. Okay, so that's it today. So it's time for the revision. We have learned certain like overview of separation of different mixture from each other that engage liquid to solid, solid to liquid stuff. So that is how we can separate them. And that's it for today, because that was the general idea. As soon as we proceed, we are going to learn other strategy for the separation purposes. So if you have any confusion, you can drop us the message, and I hope we will be replying them. Good luck.